You're listening to the N2K Space Network.
Imagine a world where you're always one step ahead of cyber threats, where your defenses are impenetrable because you see what others don't. Welcome to Team Cymru's Threat Intelligence Solutions. With real-time access to the world's largest threat intelligence data ocean, they enable you to turn the tables on attackers. Transform your security from reactive to proactive through accelerated threat hunting and incident response, made possible through automation. Empower your team with visibility and insights to start defending your organization like never before. Team Cymru. Be the hunter, not the hunted. Learn more at team-cymru.com/cyberwire. That's team-cymru.com/cyberwire.
Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes, host of the T-Minus Space Daily Podcast. Deep Space includes extended interviews and bonus content for a deeper look into some of the topics that we cover on our daily program. You know, many of us, if not hopefully most of us, know that the moon pulls on our oceans, driving the tides. But did you know that the moon smells like gunpowder? And have you ever thought about exactly how essential the moon has been in the development of not just science, but also religion? Well, Rebecca Boyle has. She is a science journalist and the author of a new book called Our Moon: How Earth's Celestial Companion Transformed the Planet, Guided Evolution, and Made Us Who We Are. I interviewed Rebecca recently about her research and her book, and her thoughts on the future of missions to explore the lunar surface.
I'm Rebecca Boyle. I'm a science journalist and author of a new book called Our Moon. It's a sort of new history of human thought and human culture through this lens of the moon and how it's influenced everything that's ever happened on this planet, from the origins of Earth itself to the origins of life on Earth, into the beginnings of human civilization, culture, and philosophy and science.
That is not a small subject area to be tackling. That is a hefty challenge to take on. That is amazing. I remember growing up, and even now, theories about the moon's nature and its influence on Earth, it has changed a lot. What is the current thinking on the moon and you know, its origin and how it has affected Earth or been part of it, or what's the situation there?
So the origin of the moon is surprisingly still not totally understood, which I feel like is sort of strange. Like, it's the moon. We should probably know how it got here and how that worked. And the fact is that we're not really sure. So we have a few good theories, mostly developed after Apollo, that sometime when Earth was pretty new, something the size of Mars now smashed into early Earth, and both planets were totally destroyed. And like, there wouldn't be an impact crater of this. Somebody asked me, like, well, where is the crater? I was like, there wouldn't be a crater. There was nothing left. Like, there was dust after this. Like, both planets were just turned into vapor. And somehow, after this happened, we recoalesced into the moon and the Earth system that we have today. And that's kind of been the broad outlines of the story that we've told since Apollo. So about 50 years now, but it's not quite that simple. And some of the ideas are because Apollo rocks initially made us think that the moon was the remains of this impactor. It was like the leftover piece. And then more recently, people have re-examined moon rocks with better technology and updated instruments and come to believe that the moon is totally indistinguishable from Earth on a chemical basis. And so that says that they must have formed from the same material at the same time, which would be very strange. Like, that would take very special circumstances for that to happen. So now we think that this collision was probably so extreme and so violent and so unique in the known universe that both planets were totally mixed and all their contents were sort of remade, and the moon and the Earth were born from the same material after they both were destroyed. And so it's a little more complex than we thought, I think.
So I'm just two giant debris clouds just coalescing and just happen to, it really, I mean, wow.
Yeah. So, yeah, the most recent theories are that it sort of formed one massive debris cloud. And somehow in this cloud, Earth and the moon sort of reformed. But we're so completely mixed that they're indistinguishable from each other anymore. And so the moon really is a part of Earth.
Wow. On its own, if we weren't having this conversation, just that phrase is very profound. Aside from the cool factor and because we're curious human beings, why do we want to study this? Like, what do we learn by learning more about the moon, aside from, like, it's there, we want to know more about it?
Partly, I mean, we just want to know why it's here and why it's so large relative to Earth. I mean, it's a really unique thing. There's nothing else like this anywhere that we've ever found. And that might be really important in terms of the development of life on this planet and how it's lasted for so long. We don't know, but it's worth asking. And also because the moon sort of serves as a time capsule for early Earth, because Earth recycles itself. It consumes its crust and remakes itself anew in these long-term geologic and tectonic cycles. But the moon does not. And so we can look to the moon to find out what might have happened on early Earth when it was being hit by asteroids after it formed, what the sun might have been like when the sun was younger and how active it was or wasn't, and what sort of cosmic rays were hitting this inner solar system at the time and solar rays. So we would learn a lot about the conditions on Earth long ago that we can't study directly on Earth because Earth has erased that past. And so, and that's a good reason to go back, just to like learn the early history of the solar system. But then I think it's also just a more fundamental question, like looking at the moon and how it was made and how it came to be around this planet, how this planet came to be, what the moon still does to Earth, how they affect each other, how they interact with each other today. All of these questions we can get better answers to by being on the moon and going back to get new samples.
That's amazing. You mentioned the moon's possible influence on life on Earth. Can you tell me more about that? That's fascinating.
Yeah, so this was surprising to me when I wrote this book. I mean, I kind of knew intuitively. I think most people have a sense that the moon plays a role in the tide. I mean, that's kind of the way that we think about the moon influencing Earth is through the tide. And the tide itself is so much more complicated than I ever imagined. Like, basically, it's all lies, what you have been told. Like, the tide is not, it's not just like, oh, you have to move your beach towel because now the tide's coming in. You know, like, that's what I thought it was like. It was like, oh, the water goes up, the water goes down, you know. And it's so much more profound than that. It's so much more fundamental than that. I mean, the entire planet is sloshing around every day, twice a day, and bulging and stretching and, you know, contorting almost in response to the moon's tug and vice versa. And just once I kind of realized that, it was like, well, what was it doing earlier on, you know, when it was closer and when it was a stronger gravitational pull, when it was nearby after it formed? And a few scientists also asked this question in the last few years. And I found this really interesting line of research that suggests that when the moon was first formed, it was much closer. And so the day was a lot shorter. Earth was spinning a lot faster. There are all these different effects on the tide and on just Earth systems because of the moon's proximity. And it would have created really powerful tides, especially in the early history of Earth. And if we think life originated in the oceans, which most people think it did, either in little warm little pools, which is what Darwin called them, tidal pools at the water's edge, or more commonly of late, people have seemed to think that it was more like in the mid-ocean ridges, in the bottom of the ocean, where the Earth's mantle is leaking into the ocean. And there's this interesting exchange of minerals and water and heat that may have been where life first sparked into being. But either way, the moon played a huge role in the movement and transport of these life forms early on. Either it was bringing in water and then making the water recede, so you'd have this cycle of hydration and dehydration at tidal pools, which can create more complex amino acid chains, which can lead to the building of proteins, which are the building blocks of life. Or even if it wasn't there, it was in the bottom of the ocean, the moon is what would have dredged these things up from the seafloor and maybe exposed them to the sun for the first time, where they could learn to photosynthesize, you know. And I don't think the moon's role in that has ever really been fully understood, or, I mean, definitely not appreciated, in my view. And yeah, I think, it really is important to consider when we think about looking for life on other planets or even other moons of the solar system, that this gravitational influence of our moon really plays a huge role in just the fundamental processes of life from the very beginning.
You blew my mind a little bit. I was thinking about the admittedly cartoony model that many of us have from science classes of the static water at the shore, right? And you see the creature coming out of the water. And maybe it's more something was yanked out of the water. You said dredged up.
Well, yeah. So this is much later after life has evolved and become more complex in the oceans. Again, like looking at where the moon was, 350-ish million years ago, this is in the Devonian period. I found this line of research because I found a really cool study looking at coral growth rings, which are like tree rings, which you can learn a lot about the oceans and the environment in the oceans by looking at these coral growth rings. And we found out that back then, 400 million years ago, the Earth spun every 20 hours. So a day was 20 hours long because the moon was closer. And so another physicist also looked at this problem and figured out that 350 million years ago, so a little after the Silurian corals, the moon was still really close. Earth spun a lot faster. The tide was really powerful. And it turns out that at this time, this is when tetrapods are first emerging onto land. And the theory is that the moon is what put them there. There was this really high tide cycle at the time. At this time, Pangaea is starting to form. So this is the famous supercontinent that gives rise to the dinosaurs and kind of, the most iconic landmass in Earth history. And it's beginning to close up at the time. So oceans are closing and ocean basins are getting shallow and long and narrow. And so the tides are really extreme. And in these land masses where this is happening, we find the first fossil evidence of tetrapods, of trackways even, of vertebrates coming onto land. And the theory is that the moon sort of stranded them. I mean, if you're a fish and you're in shallow water and the tide is rushing out like feet per minute, like it's 80 feet between high and low tide, every 4 or 5 hours. And so you better either get out of there or learn how to breathe the air and move yourself across the sand instead of through the water. And that's what happened. And I think, again, like the moon's role in this has not really been understood until really recently. I mean, the paper that sort of shows this connection that's in the book was published in 2020. So this is like really contemporary research, yeah, which I think is crazy because it's so intuitive. But, it hasn't really been shown in the paleontological record until really recently.
We'll be right back after this quick break. Yeah, I mean, what you're describing is almost like the ocean as a washing machine, just sort of churning stuff out and just shipwrecking life, and it's got to figure its way out.
Yeah, and if we didn't have the moon mixing the oceans, like, stirring a pot of soup, all of this stuff would sink to the seafloor and never be used and never generate this chain of marine life that powers the oceans and the currents and the air, the atmosphere, like all of these processes on this planet derive from the presence of life, especially in the oceans, phytoplankton and algae and other species that generate our atmosphere, and the moon is a huge reason why that happened. And it still is. I mean, more than half of the energy from ocean mixing comes from the moon's tide. And so we owe it a lot.
We sure do. My good. I think it was even in Carl Sagan's Cosmos, like he asked the question, I could be making this up, but I'm pretty sure he was saying like, why did life emerge from the oceans? And it might be maybe they didn't intend to. It just kind of splashed out there. That's really an incredible thought. Wow. So we've been talking a lot about the history of the moon. I mean, the moon's moving further away from us slowly. I mean, does your book cover anything about, the potential future for the moon and its relationship to the Earth?
Yeah, it does. It is moving away from us. And I mean, pretty slowly is like the rate at which your fingernails grow, roughly. So it's not very much over the course of, human lifespans or human timescales.
I won't notice it. Yeah.
Yeah. But, in tens of millions of years, it will be far enough away that it will no longer totally eclipse the sun. We'll only ever have these annular ring of fire eclipses in the future. But that's like far, far into the future, probably long after humans are like uploaded into AI or just gone entirely. So it's not going to be our problem. But yeah, the moon is leaving, and that will play a huge role in a lot of things on this planet. I mean, from the tide to the overall climate of Earth. I mean, the moon is one of the sort of stabilizing influences over our climate over millennia because it keeps the axis of Earth relatively stable. And if we didn't have the moon here with its gravity sort of guiding us, the planet could tip like 40 degrees. Some people think it could be even like 90 degrees. Like you'd have these really extreme wobbles of our axis, the precession of the equinoxes. And this happens on Mars. It happens on, Venus is almost pointed straight up. We know other planets have this sort of axial obliquity. And Earth's would be more extreme if we didn't have this modulating influence of the moon. And imagine what that would do to the climate. If Earth is pointed at 45 degrees or something, like the poles are pointed directly at the sun or directly opposite the sun during the equinoxes. And so the entire northern polar ice caps would probably melt or sublime, and you'd have all this injection of carbon dioxide and methane into the atmosphere. It would cause huge shifts in our climate in ways that I don't think we really fully understand. And so again, like we should be grateful the moon is here so that does not happen.
I feel like I need to go out and say thank you to the moon. It's like, thanks so much. You have already mentioned so many things in this short chat that have blown my mind. Definitely going to read your book. Do you have any favorite things that you came away from, aside from apparently a very great appreciation for the moon, but like any things that really surprised you or anything you want to share like that?
The evolution of life stuff surprised me. But also, I think I was trying to figure out kind of walking this history with the moon of how it guided our process of thought. Like after life evolves, after humans come into being, human culture starts to develop. What did the moon do early on in Earth and human history? And I was surprised at how fundamental it has been to all of these processes of human thought. And starting with just timekeeping. I mean, like time is made up. Time is a construct, and like really one primary way that we have made up time is by the moon, is using the moon to divide time and to orient ourselves in time and mentally travel into the future. As far as we know, we're the only species that, elephants might do this, whales might do this. Other like complex social species could probably have some method of communicating that we don't understand, but doesn't mean it isn't real. But as far as we know, we're the only species that says, oh, like in the 6th moon of the year, I'm going to go on vacation. Like this is how I divide my life. And the moon is the primary way that we've done that for all of human history. Even today, like we don't use lunar calendars anymore for the most part. There are some like the Jewish calendar, the Islamic calendar, some Chinese, Korean, Japanese calendars are still culturally attached to the moon. But like, civil timekeeping and like most of society does not use it anymore. But we still have months that divide up the year, and that comes from the moon. The word month is from an Old English word, month. And so it's still really fundamental to how we organize society. And I think that the depth of that and the length of that relationship surprised me, just in terms of how truly transformative it was for us to be able to mark time and use time and orient ourselves to it with the moon. I think it was more profound than I thought it was.
The relationship between humanity and the moon is somehow very moving to me because it is such a constant in human stories. And I've gone down the rabbit holes explaining to my daughter why calendars are the way they are. And it always goes back to the moon. And it always it just feels that connection is just something that, I don't know, it's a very profound feeling. Like it really feels like a connection to human ancestry. It's amazing. And I'm feeling that when you're telling me about it too, because it's like, it is an incredible, we don't appreciate our moon enough. We really don't.
Yeah.
This, everything you've told me today really has blown my mind. This is really quite incredible. Is there anything you want to leave the audience with before we conclude today?
I guess sort of this, the upshot of the book and the kind of main ideas at the end are like, what do we owe the moon now after all of this? If we haven't talked about the whole middle of the book, which is about philosophy and the origins of science and religion and kind of how we imagine ourselves in the universe. And the moon plays a huge role in all of that too. And now we're going back up there, and we have commercial landers going up there, private companies, multiple nations trying to be up there with humans again and with rovers and landers. And I just want people to think about what the moon represents to us beyond just this like kind of abstract goal to say we did it. I hope people reflect on the relationship that we have had with it through all of human history, and that it's much deeper and much more profound and fundamental to who we are than just traipsing across its surface to get some bags of sand, which I think is amazing. I think we should be up there. I think people should be up on the moon, but I think doing so really ought to require a lot more consideration of what the moon represents to all of humanity through all of time and what responsibility we have to it because of that.
I think it's a very timely question with everything that's going on with the moon right now. That is like the question. Yeah, it's a fantastic point. What we owe the moon is such a great question to leave our audience with today, especially. And I will be thinking about that as well. It's a great question. Rebecca, I could talk to you for hours, honestly. You are fascinating. Your book sounds amazing. I cannot wait to read it. And it's called Our Moon. So I'm going to make sure we have a link in our show notes for all our listeners so they can check it out as well, if they haven't read it already, which I'm sure many have. But Rebecca, thank you so much for your work. Thank you for speaking with me today. It's been a joy. That's it for T-Minus Deep Space for March 23rd, 2024. We'd always love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound designed by Elliot Peltzman. Our associate producer is Liz Stokes. Our executive producer is Jen Ivan. Our VP is Brandon Karp. And I'm Maria Varmazis. Thanks for listening. We'll see you next time.
You don't need luck when you have the right tools to help you prepare for your next IT or cyber credential. At N2K, we've helped over 500,000 practitioners level up their careers with Cert Prep training. And now you can score 25% off our best-selling practice tests, such as Security Plus, CSSP, CCNA, PMP, and more. Visit n2k.com/certify and use promo code NETWORK, that's NETWORK, at checkout to save 25% on your purchase. Offer ends March 27th. Happy learning.